section 9.1 is called a review of operations and composition. What composition means in the title? Composition just means combinations of function operations. So to get things started, I want to go over notation with function operations. The very first type of notation is if you see a problem where it asks you to find f plus g parentheses x. What this means is this means you take f of x and you add g of x to it. Similarly, if you had a minus sign between them, you would take f of x and subtract g of x. If you had them written next to each other, f times g of x like this, or you might even see it written f with a closed circle, g of x. Both of these mean the same thing. And this just tells you to find f of x and multiply it by g of x. If you see f divided by g of x, this means you take f of x and you divide it by g of x. Just one other function operation, and that's f with an open circle, g of x. This means you plug g of x into f. Of course, we'll go over answers with those. So let's go ahead and take a look at some examples. Let's let f of x equal 2x plus 1 and g of x equal x minus 5. I'd like you to find f plus g of 1. Now what this means from notation this means f of 1 plus g of 1. And what that notation means is you just plug 1 in for all x in f of x. That means. And this, of course, is a similar thing. This means plug 1 in for all x in g of x. Let's go ahead and do that. I'll maybe use different colors, at least for the first example. F of 1 means we're going to put 1 in for the x right here. So this means we're going to do 2 times 1 plus 1 plus g of 1, meaning we're going to plug 1 in for the x and g. 1 minus 5. It is a good idea when you do these to put them in parentheses. We'll see why in another example. But if you have to subtract these values, you just want to make sure that you distribute the negative in front. So 2 times 1, of course, is 2. 2 plus 1 is 3. We're going to add that with 1 minus 5 is negative 4. 3 plus negative 4 is just negative 1. That would be our answer. Very simple to do. It's just you have to know what the notation means. Next problem, what if we were doing f minus g of negative 2? And then from our notation, this means we do f of negative 2 minus g of negative 2. You don't say g parentheses negative 2. We read it f of negative 2. So similarly, we'll use parentheses here. We're going to plug negative 2 in for all of the x's and f of x. So I'm going to plug a negative 2 right here. It means we're going to do 2 times negative 2 plus 1. And then I'm going to plug in negative 2 for the g. Negative 2 minus 5. I'm going to make sure I use grouping symbols. And I'm going to be subtracting g of x. I'm going to put that whole thing in parentheses just to make sure that I don't forget to distribute anything. 2 times negative 2 is negative 4 plus 1 is negative 3. Negative 2 minus 5 is negative 7. Negative 3 plus 7, of course, is 4. What if we had f times g of 1? The notation just means we're doing f of 1 times g of 1. Looking back at our formulas, if we plug 1 in for the x, we're going to get 2 times 1 plus 1. We're going to take that number, we're going to multiply it by, if we plug 1 into g of x, that would be 1 minus 5. Two times 1 plus 1 is 3. 3 times negative 4, negative 12. And then our last example from this would be f divided by g of 7, which means f of 7 divided by g of 7. Had a little glitch. 3 times -4 is -4. We're going to do this the same way. You don't have to wait for me. I'm just going to plug in 7 for all of the x's and f of x. That's going to be 2 times 7 plus 1 on top, divided by g of 7 would be 7 minus 5 on the bottom. So 14 plus 1 divided by 2 is just 15 divided by 2. Next thing I wanted to talk about are domains. So you might have problems where it asks you to find the domain of a composite function. So domains compositions are the intersection or overlap of each individual function's domain. So let's take a look here. If we said f of x is equal to 3x plus 4 and g of x is equal to x squared minus 3, I'm going to ask you to find the following and give their domains. So first part, let's find f plus g of x. What this means is we figure out what f of x is, and we just add g of x. Whatever's in the parentheses afterwards, it doesn't mean you multiply anything. The notation just means you plug in the second parentheses and for the x's of f and g, and then add them together. So for example, we're just going to be taking f of x, which we said was 3x plus 4. We're going to add that with x squared minus 3. We always put them in parentheses just to make sure that we don't forget to distribute anything. Just distribute a 1, the parentheses cancel out. And we just get x squared plus 3x plus 1. That's what you would get if you add them together. As far as what the domain would be, look at what you're given. So the domain, if you remember, we had a couple restrictions. One thing that limits the domain, we'll call it restrictions. We talked about this a few weeks ago. One restriction was that the square root has to be greater than or equal to 0. And another restriction was that the denominator cannot equal 0. So do we either have a radical for this problem or do we have a denominator? No, right? So there are no restrictions for this. which means the domain would just be any number. The positive infinity. All right, let's try another one. How about if we had f minus g of x? What you're going to do is take f of x and subtract g of x. This would just be 3x plus 4 minus x squared minus 3. We're going to make sure we put it in parentheses because we're going to have to distribute a negative later. This would just be 3x plus 4 minus x squared plus 3. Finally, we get negative x squared plus 3x plus 7. It doesn't look like there's any radicals or denominators like we talked about. Domain would be all real numbers. You could also multiply them. Like f times g of x should be f of x times g of x, which is 3x plus 4 times x squared minus 3. Just FOIL like we usually do. Go ahead and distribute. 3x times x squared is just 3x to the third minus 9x plus 4x squared minus 12. I'm writing these terms from descending powers. We get 3x squared plus 4x squared. I'm sorry, 3x to the third plus 4x squared minus 9x minus 12. There are no domain restrictions. If there's no denominator, there's no radicals, we just say all real numbers. The last one is going to be a little bit different. The one where we're dividing f divided by g of x. We're going to take f of x and divide it by g of x. Which means we're going to take 3x plus 4 and divide it by x squared minus 3. About domain restrictions, we do have a denominator here. The denominator can't equal 0. That was one of the restrictions that we talked about. I'm going to say x squared minus 3 is equal to 0. I'll add 3 to both sides and take the square root. Anytime you take the square root of something squared, you get absolute value. This just turns into plus or minus. So the values of x that would make the denominator 0 would be plus or minus square root of 3. So you could pick any value of x that you want, except you can't use the square root of 3, and you can't use negative square root of 3. So on a number line, it looks like we could use any number up to negative square root of 3, between negative square root of 3 and positive square root of 3. Any number bigger than the square root of 3. That would be our domain. What about if f of x was 4x minus 2, and g of x is the square root of 3x plus 12? Do the same thing we just did, but with different functions. So for the first function, we're going to be finding f plus g of x, or f of x plus g of x. 4x minus 2 plus the square root of 3x plus 12. There's nothing we could really reduce here. That would just be the answer. Now we have to figure out the domain. But before, we're looking for two things for domain restrictions. One thing is, do you have a denominator? No. But we do have a radical. We talked about if there's a radical in the problem, you make the inside greater than or equal to 0. So in this case, 3x plus 12 would have to be greater than or equal to 0. 3x would be greater than or equal to negative 12. Dividing by 3, x would be greater than or equal to negative 4. So as far as your domain, you could only pick x values that are greater than negative 4, because otherwise you get a negative in the square root. The way that we say this is we say negative 4 with a bracket. Subtraction is the same thing, so we don't have to go through that. If we're going to multiply, we're going to take f of x times g of x. 4x minus 2 times square root of 3x plus 12. If you just distribute, there's nothing really to distribute here. Just wind up with 4x times square root of 3x plus 2 plus 12. There's nothing we could really simplify there. Same thing if we distribute the negative 2. Negative 2 times the square root of 3x plus 12. Maybe the same issue as before. We have a radical, so our domain, same steps that we did before. If we have a radical, we want the inside to be greater than or equal to 0. So that would happen if negative 4 and infinity. Same domain as last time. So anytime you have a radical in the problem, you have to make sure that the inside of the radical is greater than or equal to 0. So that's what we did in the problem before it. We had the square root of 3x plus 12, and we made it greater than or equal to 0. So it's the same thing here. We do the same exact process. We'd say 3x plus 12 is greater than or equal to 0, so 3x is greater than or equal to 12, and x would be greater than or equal to negative 4. Same step we did before, because we have a radical in the problem. And if we had one a little bit different? What if it was f over g of x? So this just means we take f of x and we divide by g of x. F of x was 4x minus 2, and g of x was the square root of 3x plus 12. Nothing really to simplify here, but it is going to be a little different because when we're finding the domain, the denominator can't be 0. That's one thing. The second thing is if you have a radical, the inside has to be greater than or equal to 0. Because we have a radical in the denominator, what we're going to do is say, okay, the denominator can't be 0. So the square root of 3x plus 12 can't be 0. Square both sides, bring the 12 over. We just get x can't be negative 4. Also, we have a radical, which means what's inside the radical has to be greater than or equal to 0, like we talked about before. So x has to be greater than or equal to negative 4. So in order to write this, we know x can't be negative 4. And for the second one, x has to be greater than or equal to negative 4. So the way that we would write it, the domain would just be any number greater than negative 4. A little different than before because we have parentheses. Parentheses means you can't include negative 4. Okay with this? We've seen restrictions before. Something that is on your final is something called the difference quotient. The difference quotient will be provided for you, and it just says f of x plus h minus f of x divided by h. What you'll be asked to find is to find the difference quotient. So you're actually finding 3 composite functions and then simplifying. It's not a hard thing to do. Let me show you with an example. Let's say I ask you to find the difference quotient of 2 problems. First problem, let's say f of x is equal to 3x minus 2. Well, there's 3 things we have to do here. First thing we have to figure out is what's f of x plus h. What that means is we're going to plug x plus h in for x. Right here. So instead of 3x minus 2, it's going to be 3 times x plus h minus 2. And we're going to subtract f of x. f of x is just 3x minus 2, but we're going to remember to put it in parentheses so we subtract the whole thing and make sure we distribute the negative. Then we're going to divide everything by h. So let's simplify this a little bit. I'll distribute the 3. 3x plus 3h minus 2 minus 3x plus 2, all divided by h. Simplifying, it looks like the 3x and the negative 3x cancel, the negative 2 and the positive 2 cancel. Just wind up with 3h over h, which the h's cancel and you just get 3. Difference quotient, there's kind of a lot of steps to do that, but it's not super hard to do. Another one of these, maybe we'll do one a little bit harder. What if I gave you f of x is equal to 3x squared minus 1? Do the same process. What we're going to do is plug x plus h in for all the x's. So we'll have 3 times x plus h to the second minus 1. Instead of x, we put x plus h there. Then we're going to subtract f of x, which was 3x squared minus 1. And then divide everything by h. Going to simplify it. So we're going to have to, there's no shortcut here. You can't do 2, distribute the 2. Math doesn't work like that. So we do have to distribute 3 times x plus h times x plus h minus 1 minus 3x squared plus 1, all divided by h. This would be 3 times squared plus xh plus xh plus h squared, and minus 1 plus 1 cancel. Have to simplify. This gives us 3x squared plus 6xh plus 3h squared minus 3x squared all over h. Almost done. Then let's go ahead and simplify like terms. So the 3x squared minus 3x squared cancel. We're just left with 6xh plus 3h squared, all divided by h. This is the hardest kind of problem that you'll see. So what we want to do is, once you're down to this last step and you just have a bunch of h's everywhere, we factor out an h from the top. We'll just divide everything by a GCF of h. Cancel that with the h on the bottom. The final answer for this problem will be 6x plus 3h. Question on the final is going to be like this. So that's telling you the math class you're going to take next, which is called calculus. Calculus is the study of something called the derivative and the integral. Do you ever hear of those? So what a derivative is, I'll just take a couple minutes and I'll just answer this. The difference quotient, what this is telling you is the slope of any kind of graph. You know the slope of a line, right? The slope is just m. That's rise over run, right? And we could just find slope by using our formula. What the difference quotient does is, let's say you have a graph that looks like a parabola, which is what we're going to be learning next. And I asked you, what is the slope of that line? You can't answer it because the slope changes. But this point right here, call this 1. This point will be 1 plus h. This value right here is f of 1. This value right here is f of 1 plus h. If you were going to find the slope of a point between those 2 points on the graph, so you could find the slope between 2 points. The slope would be, to subtract the y values, f of 1 plus h minus f of 1 divided by 1 plus h minus 1, which is exactly the same thing as this. Does that make sense? That's exactly what it is. It's giving you the slope of the tangent line. Question. First half of calculus is that. Second half of calculus is called the integral, which is kind of, it's finding the area under a curve. It's similar to that. If I asked you what's the area between these points, this would be like what you use the integral for. Okay. The question was, what is the significance of the difference quotient? And the answer is it's something called the derivative, which is the slope of a tangent line to a graph, which you learn more about in calculus. This is the longer section of the two. There's one other thing I wanted to go over. We didn't talk about composite functions. I just want to go through that, and then we'll finish up with our last section, which is let's talk about composite. Oh, composite function, remember we talked about before, was just a combination of functions. So we'll just get right into it. What if I asked you, or I told you f of x is equal to 3x plus 2, and I told you g of x is equal to 2 over x. So I'll ask you, find f of g of 3. What this means is you find g of 3, and then put that answer into f of x. We work from the inside out. G of 3 means we put 3 in for x here, and that's just going to be 2 over 3. Next step is we put 2 over 3 into f of x. That's all just notation. What this means is you put 2/3 in for the x. So instead of 3x plus 2, it's 3 times 2/3. 3 times 2/3 equals 2. 2, of course, is 4. That's what the answer would be. We could also do it where we're doing g of f of 3, which is just the reverse. You plug 3 into f of x, and then you plug the answer in for 3. So f of 3 would be 3 times 3 plus 2. 9 plus 2 is 11. And then you plug 11 into g of x, which would just be 2 over 11. What about a slightly different problem? If I told you f of x was x squared plus 3, and g of x is equal to 1 minus 4x. Let's to find f of g of x. What this means, just like before, you figure out what g of x is, and then you put it into f. Nothing changes because there's variables. So g of x is just 1 minus 4x. The rules stay exactly the same. So we're going to plug in 1 minus 4x for the x right there. Instead of saying x squared plus 3, it's going to be 1 minus 4x squared plus 3. This is the same as just 1 minus 4x times 1 minus 4x plus 3. Distribute. 1 times 1 is 1. Minus 4x is minus 8x plus 16x squared. Plus 3 just gives us the answer. 16x squared minus 8x plus 4. What if we switched it? What if we did g of f of x? This just means g, but you put f of x inside the parentheses. F of x is x squared plus 3, so we'll just put that right here. And we're going to put x squared plus 3 in for the x and g of x. So g of x, I told you, was 1 minus 4x. So instead of 1 minus 4x, put x squared plus 3 there. 1 minus 4x squared minus 12 is negative 4x squared minus 11.
So, it's just like 1 minus 4 in the parentheses.
Yeah, so the whole idea is that you're replacing x with whatever's in parentheses. So instead of x, you write whatever was inside the parentheses. Does that make sense? The whole idea is you're replacing. Let's get the idea with this. Okay. Maybe we'll do one more. These problems are kind of cool. This is like the last one from this section. So the directions are just to find functions f and g such that f of g of x is equal to the square root of 2x plus 3. What this means is we want to figure out what could f of x be and what could g of x be. So when we do f of g of x equals square root of 2x plus 3. You have to get a little creative for this. Anyone have any suggestions? Think about it like f of x is the big function. What is the big function here? What's on the outside of the inside? Hard to explain. Let's start with the inside then. What's on the inside of the function? That's the inside, right? This is the inside, so that's what g of x is. And we're putting that into the bigger function, which is what? If I asked you to find f of g of x, you use that line of thinking. G of x, you told me was 2x plus 3. We're going to plug 2x plus 3 into the x right there that we created. 2x plus 3. Right? Another one of these, we got it. One more. What if I told you that f of g of x is equal to 1 over 2x plus 3? And I wanted you to find f of x. And I wanted you to find g of x. So that f of g of x is equal to 1 over 2x plus 3. Similar to what we just did. It's on the inside. 2x plus 3. And 1 over x, right? G of x is the inside function, 2x plus 3. And if we were to put that in for this x over here, be 1 over 2x plus 3, exactly what we want.